to the value, you are triggering the gate current.
Today will be after the end of the semester. That's the irony of it. We'll be starting with introduction to PLC hardware part of it. We have done enough of software. So just basic concepts about PLC hardware. Now, what exactly is a PLC? It is a processor-based system. The computer. It's a computer, but it's made for a specific application. It's made for a specific purpose. And what is an application? It is basically used for automation of machines, of equipment, of processes in a factory or plant. So the application area of a PLC is very well defined. Automation, control of machines, equipment, processes, as you find either in a factory or in an industry or a process plant. Now, any computer-based system, whether it's a desktop computer, whether it's a laptop computer, whether it's a PLC, whether you have any embedded system within your washing machine, within an air conditioner, within your microwave oven, all computer-based systems have a common set of components. And that is obvious. You've already studied microprocessors, controllers. Obviously, you need to have a processor. That's the first part of it. In addition to the processor, you need to have memory. The two variants. One is RAM or volatile memory. One is non-volatile memory, typically flash. Of course, probably in a computer, you have a hard disk. Most other systems, for example, in your smartphone, you do not have a hard disk for non-volatile storage. You basically have flash memory. Very similar to context. It also uses flash memory. You basically require memory, two variants. So in addition to the processor, in addition to the memory, what additionally do you require? You require an obvious that is a power supply unit which powers all the components that goes into the computer. Now, in case of a laptop, of course, you'll say you have got a battery, but primarily you have an adapter which charges the battery, and also if it's plugged in, provides power for the operation of your laptop. In case of a desktop computer, public main supply. But if you just open a particular box, you'll find that there's a separate box which is called a supply unit. What it takes is the main supply, 2 volts or 120 volts, depending upon the country, and convert that to low-level DC. আচ্ছা, আজকেও আমাদের ইন্টারনেট যদিও কাজ করছে, তার অবস্থা খুবই খারাপ, মানে ব্যান্ডউইথের অবস্থা খুবই খারাপ। What it does is take the main that is 220 volts AC and converts that into low-level DC voltages that is necessary for the operation of all components within the computer. And এখন কি অবস্থা? এটা যাচ্ছে না বোঝা যাচ্ছে?
ওই একই রকম।
স্যার বোঝা যাচ্ছে না কিছু।
সেটা তো আমার ইন্টারনেটে দয়া। দাঁড়া, একটা মাইক্রোফোন যদি প্লাগ ইন করতে পারি।
কম্পোনেন্টস অফ এ পিএলসি শোনা গেল না, কেটে যাচ্ছে। এখন কি অবস্থা? মাইক্রোফোন পাল্টে একই অবস্থা?
আচ্ছা,
শোনা যাচ্ছে স্যার, শোনা যাচ্ছে।
আগের থেকে
ঠিক আছে স্যার।
তাহলে আবার মানে অ্যাকশন রিপ্লে প্রথম থেকে? আগে কিছু শোনা গেছিল, মানে বোঝা গেছিল, শোনা তো গেছিল। হ্যাঁ,
আগেটা প্রিলিমিনারি জিনিস ছিল, এখন চালাবো।
আচ্ছা, okay, fine. So we are basically trying to look at the various components of a PLC in terms of hardware, of course. So the obvious components is, of course, you have a processor, you have memory, both two variants, RAM and flash. Third, you have a power supply unit, which takes the power from the mains and converts that into voltage levels that is required for the operation of your electronics. Remember, as days go by, the processor supply voltages are becoming lesser and lesser. BD taught you this one, TTL, this one, logic, that operates of 5 volt supplies. Then we had LVTTL operating of 3.3. Most processors these days operate at either 1.8 or 1.2. Probably it's going to go to 0.9 at some point of time, because lower the supply voltage, lesser the power consumption. So you need very low level DC voltages for the operation of the electronics, and that is the basic responsibility of a power supply unit. So finally, we have a processor, we have memories, we have power supply. Another important component that we have is inputs and outputs. Now let us come to the context of your laptop or your desktop computer. You have input devices. Primarily, you have a keyboard. You have possibly a trackpad if it's a laptop. Output device basically is your monitor. But since a PLC was basically designed for a specific application, it is meant for automation of machines, of equipments, of process in a factory and in a process plant. So the requirement was that this particular computer should be able to interface with a wide variety of field devices. Field devices means two things. It could either be input devices or sensors. For example, a switch, a push button, that's not a sensor, but it's an input device because by pressing the switch, you can give a manual input to your computer. You can tell your computer to do something. Of course, even in case of a laptop or this one, desktop computer, you have switches. All your keyboards are basically switches. The clicks on your mouse are basically switches, and that gives your computer an input, a command to do something. But here, in case of a PLC, it is supposed to connect to a wide variety of sensors that is used in the process. And at the same time, it is also expected to connect to a wide variety of output devices. Output devices could either mean actuators. Actuators, for example, it could be relays, it could be solenoid valves, it could also be lamps. A lamp is not an actuator, but it's a visual device which gives some kind of an information to the operator. So the fundamental requirement was, since you're going to use this in a factory for automation, you need this particular device, or this particular device should have the ability to connect to a wide variety of input and output field devices. So that was a fundamental requirement in case of a PLC. So a PLC has something that is known as an input interface and an output interface. Now, what is the job of this input and output interface? The job of the input interface is to take signals, to take inputs from field devices and convert that into an information that the processor can understand. Ultimately, you're giving all inputs to the processor. Remember, it is your processor which takes the inputs and then solves the user program, the logic that you have defined. So all inputs coming from devices in the field, all inputs coming from sensors in the field, that information has got to be conveyed to your processor. So the basic objective of the input interface is to take the input signals from the sensors and convert that into something that is acceptable to the processor. So what exactly goes into an input module? We'll discuss that shortly. Output module is just the opposite. For example, in your program, say one output becomes one, and that is used to drive a lamp, or that is used to turn on, as you did, a pump. So how do you turn on a pump? Of course, you need some kind of a relay, or you need some kind of a contactor which is connected to the output of the PLC that turns on and operates your pump. So again, the job of the output module is to convert the output of the processor. Remember, the logic level output of the processor is around what, 3.3 volts, 1.8 volts, or probably even lesser. Plus the amount of current that it can source is extremely small. So this low-level logic signals has got to be converted into something, into a form that can directly drive field devices. That could either mean actuators, or that could either mean indicators that you have within a machine, within a process, or within your equipments. So input and output interfaces are basically hardware, are basically electronic circuits whose purpose is to convert signals from sensors into a form acceptable to the processor, and the output of the processor into a form that is acceptable to actuators and indicators. Now here, the input and output could be of two different forms. It could be what is more commonly referred to as discrete input or digital input. That is a two-state variable. For example, the state of a switch, the state of all kinds of switches, whether it's a manual switch, whether it's a proximity sensor, whether it's a limit switch, whether it's a temperature switch, whether it's a flow switch, and the list goes on. All these devices provide you with a two-state output. So any hardware that is designed to accept such a two-state signal is referred to as a discrete input or digital input interface. Similarly, you have devices who have two-state outputs. Indicators could either be on, it could be off. A solenoid valve can be on, it could be off. A relay or a contactor could be on, could be off. So again, you have hardware that converts the output of the processor into a signal that can drive any output device, lamp, relay, solenoid valve, contactor, and so on. So such outputs are referred to as discrete outputs because such outputs can only take on two states. One is logic state 0, the other one is logic state 1. A second category of inputs and outputs are referred to as analog inputs and analog outputs. For example, if you have a signal from any kind of a transmitter, all transmitters provide a 4 to 20 milliampere signal. It's a continuous signal, it's an analog signal. If you have a signal directly from a thermocouple, if you have a signal from an RTD, if you have a signal from a load cell, which is a millivolt signal, all such signals are continuous signals or analog signals. So in this particular case, you need an hardware which accepts this particular signal, converts that into a binary pattern, into a digital number, into a binary number, which then becomes the input to your processor. And similarly, you have analog outputs. For example, say you want to drive a control valve that you have studied. So control valve position can change from 0 to 100%. It is a continuous variable. You know that you have a 4 to 20 milliampere signal coming out of a controller that's converted into a pneumatic signal, and that finally operates a valve. So here you have a requirement that you require a analog output. So as far as input and output hardware is concerned, there are four types, two types of inputs, discrete inputs, analog inputs, two types of outputs, discrete outputs and analog outputs. Now, this is what is special to a PLC. For example, I want to connect a switch to my laptop, if I want to connect a bulb or an indicator to my laptop, you cannot do it directly. There's no such provision either on your laptop or in your desktop computer. You require additional hardware. The most common hardware would be some kind of a device on your support. So that switch port you recognize that. It's the computer you have any such output hardware special hardware or USB port on the device to produce a discrete output. So that's the difference. In addition, a PLC also requires communication interface. Communication interface,
Voice
why?
is not
There are
clear,
many
sir.
reasons why you require it.
কল্যাণ জাস্ট মিনিট খানেক ধরে তোমার
I
ভয়েসটা
understand
আমার
that.
কাছে জাস্ট 1 মিনিট ধরে
মানে net যদিও
বুঝতে পারছি হ্যাঁ
যা দেখছি কিছুক্ষণ পর পর টাকা ঘুরে যাচ্ছে আমার সামনে ওইটাই buffering মাঝে মধ্যেই buffering দিচ্ছি so theoretically the connection is working but bandwidth মনে হয় তোমার is horribly poor
ঠিক আছে
যাই হোক আবার রিপিট করার চেষ্টা করছি you require a communication interface. When you require a communication interface on a PLC, as the name suggests, you're trying to communicate with something. The PLC is trying to communicate with something. এখন কি অডিও একই রকম পুরো ঘাটা
না বেটার
আচ্ছা
একটু বেটার
now why do you require why does a PLC required to communicate with anything? The first the obvious requirements, whenever you have a PLC, you obviously need to have an user program. What is a user program? What you've been doing this entire semester. You have a laptop, you have a computer, in that you have an application like Codesys, or if you're a Siemens fan, you have a Siemens DIA portal. If you have an Allen Bradley fan or Rockwell fan, you have RSView or some similar software. They are all very similar softwares. And that is where you define the user that you want to run within the PLC. So that particular program that you want to run with the PLC is defined within a computer, which is a laptop or a desktop computer, and is running an application like Codesys or something very similar. So once you've developed the program, what you did so many days is you press that online. What that actually does is when you press that online, the compiled version of the program gets downloaded onto the memory of the PLC. Because remember, your program is developed and compiled within your programmer. Programmer is your laptop running Codesys, and that is run on the PLC hardware. So this particular exe file or the compiled version of your user program has got to be downloaded where onto the memory of your PLC. So obviously your a laptop which is running Codesys and a PLC requires hardware connectivity. There's some means by which you need to transfer this file from your coach's environment onto the memory of the PLC. কি অবস্থা কথার বোঝা যাচ্ছে কিছু না ডিস্টর্টেড
না বেটার বেটার
আচ্ছা যাই হোক so you want to download this particular program so there is a requirement that you need to connect your PLC hardware or your PLC to this laptop which is running courses. So any PLC requires a user program, and that user program is always developed in a courses-like environment, which is running either on a laptop or on your desktop computer. This laptop or desktop computer running the courses or similar programs is what is called a programmer. Why programmer? Because that is why you're developing the user program that is going to run on the PLC, right? So you always require a programmer and you always need to connect this particular programmer to your PLC. So how do you connect? Unfortunately, most PLCs do not have Wi-Fi support till today. So earlier there are different forms of connection. They used to use RS-232 and whatnot. But as of today, all modern PLCs use Ethernet connectivity between your laptop or your desktop computer has a standard RJ45 for Ethernet connections, and your PLC also has a RJ45 for Ethernet connectivity. So you can simply take a cable, Cat5, Cat6, whatever, connect the two Ethernet ports, one on your laptop, the other one on your PLC, and that way you can establish a connection between your laptop and your PLC, your courses environment and PLC. You can transfer your program, and when the PLC is executing the program, when you, for example, after online you press run, that is, you command the PLC to run the user program, and then you can see the status of the program in real time. So again, there's communication. The program, remember, is being run on the PLC hardware, and that particular status, real-time status, is being transferred by the communication link to your courses environment, where you can see the logic being executed in real time. You can debug if you have any problems. Plus, in a physical PLC, what is very important is if there's any hardware fault within the PLC, PLCs are always built with extensive diagnostics. The problem is if your PLC goes down, if there's a failure in the PLC, then your plant goes down, your machine stops, your equipment is no longer working. And in a factory, if your equipment is not working, if your process is not working, first of all, you have downtime, that is, you have economic losses, but there could be many other dangerous consequences if it's handling dangerous materials, for example, in petrochemical plants. So their failure is simply not acceptable, right? So you need extensive diagnostics. The PLC is continuously monitoring the health of the entire system, of the entire hardware. And in case there is any malfunction anywhere, that is immediately communicated to your programmer. On your programmer, you can immediately see that some particular piece of hardware is malfunctioning. So what you could do is you could simply replace that particular piece of hardware. I'll come to this concept later, because PLCs are made in such a way so that the replacement of hardware becomes very easy. That's not a case in case of your laptop. That's not a case in case of desktop computer or most of the hardwares that you have. But PLC is specifically designed so that if one piece of hardware malfunctions, it becomes very easy to replace that particular hardware within a very short amount of time. You could even have redundancy. Redundancy means instead of one processor, you could have two processors, you could have three processors operating in parallel, so that if one processor fails, if one processor fails, the input or output device fails, there's backup. You have an extra wheel in your car, probably four wheels have an extra wheel, so that will, this one fails, and happens. You can have actually two rotating problem is the amount of time to remove the defective wheel and put in the spare wheel. So for that amount of time, your vehicle is not working. In a PLC, okay, one hardware malfunctions. What you do is remove that hardware and replace it by similar hardware. So during this replacement duration, your PLC is not working, so your process is not working, equipment is not working, your machine is not working. Before doing that, so in that case, what you do is you have two, three, multiple processors, multiple output interface, multiple interfaces. Everything can be replicated. Everything can be duplicated. Technically, you say that you're making it redundant. You're making hardware redundant. You're using multiple pieces of hardware to do the same job. The idea is one piece of hardware fails, there's a second hardware, identical hardware, which can take on that particular responsibility, which can continue with job, so that you do not have system failure, you do not have equipment failure, you do not have process failure. So that's a very important requirement in case of a PLC, which is not there in case of your laptop. Your laptop fails, fine, nothing. Call your HP, call Dell, or take it to your local technician. He'll take his time to repair that. But you cannot afford that in case machine, you cannot afford that in case of a process, you cannot afford that in case of an equipment. We'll come to that aspect. But remember, diagnostics is a very important concept in case of PLCs, in case of all equipment that is used in industrial applications, and you need to see the status. Where do you see the status? Typically on your programmer, on your code environment, on your Siemens TI environment, and that is one important reason why you require communications. You also require communications from the PLC for other reasons. For example, while a computer or a laptop has a display device, okay, a laptop has a display device, has a monitor built in, but a desktop computer does not come with a monitor as a integral part of the system. I mean, you buy the monitor separately, you buy the tower or that particular computer hardware separately. Then what you need to do is you need to plug in it on that computer. You got an HDMI interface or whatever, and there you plug in so that it can display particular information. PLCs typically do not come with a monitor. They do not have a monitor. But if you want to have a display, what do you want to have a display? If you want to have a graphic user interface, if you want to have a visualization, typically it was HMI. Normally, PLCs come with an HMI so that user can give their inputs and you can observe the status of the system. You already know you've used visualization quite extensively. So where do I generate this particular visualization if I don't have a display device? Here you've been doing everything within a computer. But when you are using that program in a PLC, the PLC by default does not come with a display. So you need to connect a display to this particular PLC. How do you connect? Again, you require a separate display device which communicates with the PLC. So you require some kind of a communication interface on the PLC and on the display device. Again, as of today, that's an Ethernet interface. Third, you could require, normally what happens in a large plant, you have multiple machines, huge number of machines. The process could be quite big. There could be multiple equipments, and you normally don't have one PLC doing the whole job. You have multiple PLCs, each possibly dedicated for one machine, one equipment, or one portion of the process. Now, if I have multiple PLCs, and if I want a common HMI, that is, I want to sit at one place and see information from the entire process, from the entire plant, from the entire equipment, from the entire machine. So what you need to do is, you need to establish, as you can guess, a local area network of the PLCs. Of course, it's called a control network. It's exactly the same concept as local network, area network of computers. You need to connect all these PLCs to a local area network, which then connects to a centralized HMI station. That is basically a computer which collects information from all the PLCs, that it collects information from the entire process, all machines in this particular factory, all equipments in the factory. All the data is brought to a centralized computer, and there you have that visualization, more commonly referred to as HMI. You did one page, they'll have many pages of such visualizations, which gives you information regarding the entire machine, entire plant, entire process. So obviously, since you need data from multiple PLCs, you need to connect all of them in a network. And again, for that, you require a communication interface. Again, typically that's an Ethernet interface. So a PLC requires a communication interface for multiple reasons, and that is why a PLC by default has communication interfaces. And the last thing is this mounting system. I'll come to this a little later. এখন অবধি শোনা যাওয়ার কি অবস্থা এখন কারেন্টলি অ্যাজ ব্যাড নাকি ওকে
মোটামুটি বোঝা যাচ্ছে মোটামুটি বোঝা যাচ্ছে
ওকে ফাইন দিস ইজ অ্যানাদার ব্লক ডায়াগ্রাম সরি হ্যাঁ বলো
এই যে একেবারে ক্রিস্টাল ক্লিয়ার নয় ঠিক আছে কিন্তু ম্যানেজ করা যাচ্ছে
মানে ইংরেজি বলে মনে হচ্ছে তো
হ্যাঁ ইংরেজি বলে মনে হচ্ছে
মানে বাংলা বলে কেউ কনফিউজ করছে না তো this is a typical block diagram, just showing the different blocks in a PLC. Obviously, at the center is CPU, linked with memory. Obviously, you have memory, two variants. You have a power supply. Any electronic device requires a power supply. No surprises there. As I said, input. Okay, forget this module term. Why they're calling it a module? Just consider it's an input interface. What's been shown here is multiple types of devices. They've shown a push button. They've shown this one level switch. They have shown a limit switch. They have shown a pressure switch. But these all are devices with two-state outputs. It's not necessary that you only have inputs which are two-state inputs. You could have analog inputs as well. So you have input interface. It's a hardware which takes signals from sensors or input devices and converts that into a form that is compatible with the CPU. On side, you have and again, shown as a motor, a solenoid, a speaker that is an audio alarm, a indicator or light. Again, all of these are two-state outputs. Not necessary that you only have two-state outputs. You could have analog outputs as well. And of course, you need a programming device. Without a programming device, you can never actually use a PLC. Of course, a programming device need not be always connected, but it needs to be connected initially for programming, for downloading a program onto the PLC. And subsequently, it may be required either to modify the program or to have a view of the diagnostics or similar requirements. Programming is a device is always, but may not be always connected to your PLC. Now that is what is being written over here, the different components in terms of processors, I/O interfaces, power supply, communication, mount systems. Okay, this figure is basically as a PLC by default does not have a display device. Could have a PLC without a display, could be doing job perfectly fine, even without having any kind of a display device. In most cases, you do require a unit. Why? To print the visualization part, to present the HMI part, both to generate displays and take units. So this is a typical display device, which is designed, of course, it's an LCD device. It is specifically designed for use in industrial environments. Okay, before I do this, one thing, okay, your PLC is a computer-based system, is a processor-based system, and your desktop or laptop is also a processor-based system. Then what basically is the difference between a PLC and a desktop computer? Or what's the difference between a PLC and a laptop? Let's try to just have a look at particular features. Okay, I missed out that particular slide, never mind. Okay, what are the differences? The first or the primary difference is the application area, is application domain. It comes to a laptop, so the computer, person who does not know the application with that particular laptop be used. You could be using a laptop to play video games. You could be doing complex mathematical calculations using a MATLAB-like environment. You could be simulating complex circuit as you have done in PLC lab, some kind of an a VHDL programming or running PSpice to simulate analog digital circuits. That could be one application. You could be doing editing of video, editing of application, or something as trivial as writing a letter or entering data into a spreadsheet or simple browsing of the internet. So they are completely varied applications. But in case of a PLC, the application is very well defined. The person who's making the PLC very well knows where this particular PLC would be used, for what application this particular PLC would be used. So in case of PLCs, the application area is well defined, unlike what happens in a computer. A computer is a general piece of generalized computing device, could be used for a wide variety of applications. You download the necessary application onto your operating system, and then, of course, you can do your you can do the job that you're interested in. Second difference, since a PLC is specifically made for use in an industrial environment, it has got to be extremely ruggedized in terms of hardware. Now, what is ruggedized? First, it should be capable of operating at elevated ambient temperatures. Typically, PLCs are made to withstand ambient temperatures up to 50 degrees centigrade. That's quite high. No PC, no laptop would run at an ambient temperature of 50 until and unless you go for industrial grade laptops or industrial grade PCs. Second is, it should be capable of operating at high levels of humidity, 50% if it is condensed. Condensing means the humidity in the temperature does not electronic. As long as it's not condensed, humidity level of 95% is okay for a PLC. Should be capable of operating in extremely noisy environment. Electric noise. You go to an industrial environment, you have a large number of modes of very high rate. You could have
রাগেডাইজের পর থেকে শোনা যাচ্ছে না কিছু, রাগেডাইজের পর থেকে কিছু শোনা যাচ্ছে না, ওটা আর একটু কেটে কেটে আরেকবার বলবে?
যেটা বলছি। আচ্ছা আচ্ছা, এদের কি অবস্থা বলো তো? ক্লাসে যারা আছে তাদের আছে পরীক্ষা ডেট ডিক্লেয়ার হয়েছে?
সায়ন কোন পরীক্ষার ডেট দিয়েছে তোমাদের?
তাহলে আজকে ভাবছি আজকে খালি ডেমো আজকে
আমি সেটাই ভাবছিলাম আজকে খালি ডেমোটা নিয়ে নাও। এই অবস্থা খুব একটা ভালো নয়, বুঝছি না।
ওরা স্লট দিতে পারে, সবাই দেওয়ার দরকার নেই যারা ইন্টারেস্টেড, এইটা আউটসাইড দি ফর্মাল। সবাই তো নয় তো
তোমাদের
কি করবে? আমি কতটা আমাকে শোনা যাচ্ছে?